Another exciting project by Aksun Electronics Technologies Limited. On today's installation, we will be taking you through how we design a solar carport for our clients. This is actually a returning customer who trusted our brand and decided to call us again for another solution. At Aksun Electronics Technologies Limited, one thing we always deliver is integrity. So we went in with our welder who was responsible for constructing the framework for the solar carport. Work started immediately. Our bricklayer began the groundwork by digging and prepping the foundation, while every necessary steps were carefully carried out to ensure a strong and durable structure. And here is the final framework for the solar carport. Strong, well structured and carefully built to support the solar panels while providing shade and protection for the client's vehicle. Now to the main installation. Our team began by carefully offloading the materials needed for the project. For this system, we are installing 16 units of 650 watt solar panels, and 11 kVA hybrid inverter and a 20 kWh lithium battery to provide reliable and efficient power for our clients. Without much delay, all hands on deck. You can see the team member carefully lifting the mighty 20 kWh lithium battery, and trust me, this is not for the weak. Then quickly, unboxing began. We unboxed the 20 kWh lithium battery. Wow, what a beauty and a beast at the same time. The powerful 20 kWh lithium battery built to deliver massive energy storage and reliable power for our clients. Here, the team member moved on to the exterior part of the job. The installation of the solar panels on the framework began immediately, with everyone working together to ensure each panel was properly aligned and securely mounted. Now, the team leader is taking
Hi guys,
the clients.
welcome to this channel. So, we are in a resident of one of our favorite clients here. He has been patronizing us for a couple of years now. We did the setup, and we have a 3.5 kV choice inverter here, still working right now. And we have Carport lithium battery, 5 kilowatts Carport lithium battery, and right here we have our Felicity 60 amps MPPT controller. And right on the roof we have 12 pieces of 20 watt panels that are connected to each in series, they're parallel for this particular controller, and they've been using it now for a couple of let's say 2-3 years there about now. It's been serving them here, right, serving them well. And they gave us a call some months ago that, God, I want an upgrade. I want something that will be able to power my AC. There's one AC in the sitting room, one in my bedroom, and be able to pump water. There's a pumping machine switch right here, but it's not connected to this. So after the upgrade now, we'll be placing this pumping machine on the new system. So now we are taking this old system now to around 11 kVA inverter system. So we're placing this 3.5 kVA inverter to an 11 kVA inverter, 48 volts, and this battery here also is going to be replaced with a new bigger version of lithium battery. See what 20 kilowatts is coming right here. So which means the inverter we're using is an hybrid inverter, so we'll be notifying everything here will be out, and then the whole system will come in. So watch out for this space, and let's see how we transform this space. What's it called? Grid source here is back, so that's why you can see an automatic voltage regulator here. So because of the grid, I can see what's coming in. We have 157 volts coming in from the grid and 220 volt source. So this is the one regulating this voltage for the grid, so that they can have a stabilized voltage in the home here. So let's see how we can transform this and do the upgrade. So then we'll come back for the review. Thank you.
Next up, the unboxing of the powerful 11 kilowatts hybrid inverter, the heart of the solar system, ready to convert and manage the energy from the panels efficiently. Next, the team mounted the inverter carefully and positioned the lithium battery. All the necessary wiring and protection boxes were installed to ensure the system operates safely and efficiently. And in no time, our team leader is here to take us through the brand new setup. You better grab your popcorn because it's going to be an insightful and educational moment.
Welcome back, guys. So now, look at this place. Look at how transformed it is. So we are done now, and you can see how the space has been transformed. Now we have our inverter, 11 kVA inverter. Then we have our protection box for the PV. We have the breaker. This is breaker for PV1 and the surge. This is breaker for PV2 and the surge. That's for the second protection box. We have our voltage protector for the output. We have the surge. Then for the input, I have the input breaker. Our inverter, and then our double here, 20 kilowatts CW lithium battery, 20 kilowatts, 48 volts. So the battery is on currently. So now we're putting on the inverter for the very first time. Let's do the test and see what we have here. And then I'll also be doing my setting configuration. So come along with me, let's do this together. Put it down. You know, there's one thing I love about our pre-sale premium inverter. And what is that special thing? For the fact that I've connected my communication cable with the inverter to the battery without not even going to the settings to select what type of battery I'm using. Automatically it has detected that I'm using a lithium battery and it's already communicating. Can you the camera closer and let's see what we have here. Now you can see Ella, meaning that my battery has been detected that it's a lithium battery. 52.9 volt, 30%. Now let's go and check from the battery. 52.9 volts, can you see? Let's check the percentage also. 33%. So this already signifies to us that our battery and our inverter are communicating good, quite alright. So now let's start with the configuration, but before I do that, let's check our PV also. So let's put up PV1. Currently we are still on grid, so while on this video I'm going to switch back to the inverter. So PV1 is sensing PV1 currently and it should start charging now. Can you see? So now charger started. Now from PV1 we have 300 and something volts going to the inverter. So this area shows that the energy from the solar is going through the inverter and then from the inverter is going to the battery. Also from the whatever we are generating is also going to the load. The load is zero currently because we haven't loaded the system. Can see our nitrogen is still on grid. So let's check PV2. The second PV should come on, can you see? It's also blinking. It should start moving on now. Anytime soon. It start moving anytime soon. Yeah, can you see that now? So now we have both PV1 and PV2 going straight to our inverter. It's an upgrade system. So which means even if the battery is very down or it doesn't, or there's no battery here, once you have PV, the system can power your load. So now it's charging. As it's charging, it's also indicating here that it's charging. And then we have a supply of 230 volts. Same thing we have with our output voltage protector here. So I'm going to be doing a setting of this. I'm also going to explain how we do settings for voltage protector. For those of you, more especially the installers, that after you are done with the installation, you don't know how to go about the settings of a voltage protector, don't forget what a voltage protector does is it will protect against short circuit, protect against overvoltage, undervoltage, and even high current or low current, so depending on whatever type of whatever value of current you are setting on this. But within that shortly. So back to the inverter now, so it's charging already. So I'm going to enter the setting mode. You press the enter now. Yeah, so now we're in a setting, and then the first one is O1. Now, based on our Afri Cell manual, O1 means output source priority. Output source priority. So I'm going to press enter. SOL means solar is your first, is our priority, is our first priority. That's the best way. But in this, I don't know to take you through, but the options we have actually options here. We have SOL, which means solar is our first priority, followed by electricity, followed by battery. So we have SBU, solar as first priority, battery as second priority, utility as third priority. And then we have utility as first priority, yeah, that's the meaning. So for what I like using, especially when solar is our major source of energy here, so is SOL. So I'm going to be using SOL. Which means solar is my first priority, and if there is no solar, you should move to grid. If there's no grid, you should move to battery. Enter. So the O2 is the maximum charging current for the system. So I think the maximum should be maybe around 150. I'm going to be playing with the maximum. And I want to go with the maximum there now. So now is that. And the next is AC range, AP's range. APN means 90 to 280, and then we have UPS, which means 170 to 280. So I like going with 170 to 280, so that when we 90 to 280, we won't have a voltage that will pass through and then go into the house to damage your loads. So I like using UPS, which is 170 to 280. Enter. So 4 is gray tie. I don't need anything for here. Then battery tie. Enter. Though for the fact that it's less the battery, let me to pick lithium. So LIB. And then 6. I have nothing to do with 6. 7. I have nothing. 9. That's the frequency of our output. By default is 50 Hz. That's okay. That's what our loads need. Then the output voltage. Take this down to 220. I like using 220. That's my terminal output source. Then 11. 11 is maximum the current your grid is going to use to charge the system. Because grid is poor in this area, so I'll be going with 10 amps. 10 amps. That's the reason why we're having the stabilizer here. Can you see? The grid is poor. Look at what grid is supplying. 127 volts. So that is very poor. I think we stopped at number 11. Yeah, number 11. Let's go number 12. So we want to put utility and NEPA to charge at the same time. So 19, we don't need that. 20, that is our backlight for the screen. We want it to be always on. So when we do alarm, leave that as default. 23, leave that as default. 25 default. Yeah, 26 bulk charging. Remember what stated for us is 57.6. So I'm setting that. Most installers does this mistake very much. I've come across a couple of some videos and they met some kind of installers that they will think that because your inverter and battery communicate. So therefore, you don't need to do your settings for bulb voltage, float voltage, and cut-off voltage. It is very, very important you do these settings. It's very, for the fact that they still communicate, it doesn't mean that you shouldn't do these settings. The people who designed this inverter and they put that option there wants you to do it, so that in case sometimes if these guys fails to talk to each other, it's that settings that's going to go with. And then it also help your battery not to enter sleep mode whenever your battery is low. In the sense that they now start calling you and then you now go back to your client's house and to come and wake up the battery. Most especially for systems that does not even have wake up function for the inverter. You get it now? So let me go back there now. So we are at 26 bulb charging. So 56 and 57.6 is what C was stated. I'm taking it right there. Enter. So my next is float. Float. I like this 54. The float should be lower than your bulb voltage. Make sure it's lower. Yeah, before. So the next one is cut off now. What C was stated here is 48. Remember, I do say make sure you have at least 0.5 volts added to your cut off voltage, so that your battery will not enter sleep mode once the voltage is low. The PMS won't do what? It will shut down. So let's go back there and do that. That's 29. 29. What about the 29? So I'm taking it to 100.5. So that my inverter won't get to the level that the BMS will have to cut itself off away from the system. Get the point now. Then 30. I leave it as default. That's the equalization. Equalization voltage. I'll take it to 0.6. Then for the duration of your equalization voltage, I like using 7 days. So which means for every 7 days, equalization should occur. So I have others remain the way it is, and I think that's all. That's all. So you can escape. So we're done with our settings for our inverter. Let's navigate to the page of, well, let's see how our system is performing. Right here means this is the load we are consuming right now. So currently now these are 4-bedroom apartments, residential home is consuming this. You get it? And then our battery is charging, you can see. And it's our battery low currently, and our battery is at 4%. Now let me get to the page. So this one is coming in on PV1. Is the voltage. It's PV2, the voltage. This is for grid, but there is no grid currently. We shut down the grid. And then this one is going in to the battery currently. Our load has taken the remaining. And then back to our main page. So now let's come back. Let's come to our main our video plate over here. Let's start with our output. So let's start with our output. We have 4 buttons here. We have up and down, we have mode, and we have off. Now you press on mode. Depending on the kind of product of voltage regulator you are using, that positioning could be anywhere, depending on product. But mine This is the second from the right. You get it? So I press mode. The first one is countdown timing for before it switches. And then this is my voltage. So for my voltage, I'm not using 240 volt max. So I'm going to reduce this to 240. So 240 volt means that if my voltage exceeds 240, it should cut it off. So let's move to the second one. Low. I like going as high as 180. 180 is okay, safe for your load. Remember the range we choose here was even 170 to 280. That's for EPS. So, and then we have arms now. Now this is the main place now. What is our inverter KVA? 11 kV. That is 11,000. I will remove my power factor. My power factor should be around. I like using 0.9. Though for every big inverter, they must design that system to be a power factor of 1. But I don't like going with maximum. I don't like building my inverter to maximum. So let's use 0.9. So use 0.9 now. That is 9,900 watts. Excuse me. So you define whatever you have by your output voltage 220. I have 35 amps. So which means maximum load our load can draw from this system is 45. So you set 45 there. So that's modified. So I save. And I confirm again. That's that. So now for our grid, we're also going to do the same settings. For overvoltage, undervoltage, 180. And then for my current, for the grid now, remember that for the grid input, we are going to be adding our load together with the current for charging. Remember we set it to 10 amps. So if I add 10 amps to 45, which one have a maximum for our load? That is what? 55. So we'll be using 55 our current here. So that's that. And that's that for our setting. So now let's see what our wonderful system is performing right now. This is our pump with the older setup we had before. The pump wasn't on it, but now we place the pump on this now. So we can even put it on. Now you can see our pump is on. See what we're drawing. We're drawing 1.79 kilowatts of load from our available. We're drawing 9 amps currently. Can you see? Now let me go put on the AC. Come with me, please. So I'm obviously for the we have the gen power mode out on the AC. So I'm putting it on right now. So after a couple of some minutes, I should pick. So I've set it on gen mode 1 now. So after a couple of some minutes, you should pick. Let's go back there, but let's see what we are trying currently. So it's working together. The pump is running currently. So you can see the pump is running currently. The AC also is running. So now we're having our 10.2 amps. It should increase more than this once the AC peaks. So I think our system is performing well. If you need something like this for your home, for your offices, business, contact us. Just DM us, contact us. This is just for a token of 6.5 M. So just contact us. And we deliver anywhere, we deliver nationwide.
Also, the team leader takes a moment to give a talk on the solar carport, explaining its benefit, design, and how it delivers a reliable energy for the client.
Yeah, so this is where he decided that before we have them on the roof, I'll show you the video.
This is a quick video of the existing solar panels on the roof.
But now he said he wants it to be a carport whereby you can even have something to shade his cars. Then, so right here we have 16 pieces of 630 tuner solar bifacial connected in series, another 8 connected in series to give us 2 strings. So it's those 2 strings you saw right inside while doing our presentation of what we are generating. So this is a beautiful solar carport we have for this project right here. It's wonderful. It's wonderful. So you can see how beautiful it is. And it's very strong. Very strong. That's very strong. Beautiful system right here. So contact us if you want something like this. If you want a solar carport, contact us.